Hello, everyone. Thank you very much for joining my session today. We'll cover quickly about what's the current structure for like a secure software development lifecycle, and then we're going to expand a bit more on like what are the trends, what are the new things in the SDLC process that actually is trying to also optimize and also enhance the security measures put in place for securing the SDLC. So traditionally, we're talking about like it used to be more of a waterfall process. You're developing, there was a for a certain amount of months, then you're trying to integrate with other components and so on and so forth, test it, and then only after that it's going to production. We're talking like 12, 24 months process and so on. The modern approach is a lot more agile. You build, you test it, you iterate, and keep improving it in like small chunks and so on. And now with the cloud approach where you can actually have a lot more microservices, it's fully automated, you can actually build an entire CI/CD pipeline and to scale way faster. And this is something that drove a lot more in adopting new technologies, adopting new products, but also libraries, components, and so on. This is where the entire boom of the SaaS products and applications started years ago, but at the same time, that comes with a risk as well. So as you're seeing here, there's a huge amount of numbers when it comes to what are the vulnerabilities attached to adoption of containers, what are the numbers when it comes to malicious images or even libraries when it comes to public repositories like NPM for Node, PyPy for Python, and so on and so forth. And as you're seeing, this first bullet point, most of the breaches were caused by web applications. And that means one thing, right? We're developing way faster, we're building a lot more applications, and that is caused also by adoption of all these third-party components, dependencies, if you want to call them. And that can be open source, can be commercial tools, or can be even like other products, commercial products that are embedded in your platform. As you can see here, it used to be that you had like a couple of thousands of vulnerabilities reported a year. Now we're talking over 2,000 per month, over 70 per day reported, and it keeps growing. And most of them, we're talking about being high-end critical vulnerabilities. And that means security is taking a lot more seriously nowadays. The entire goal for us is to not just be able to detect, but also remediate these vulnerabilities. And that means one thing. If I'm depending on a library that has a critical vulnerability, I need to actually get a new update from that library that is fixing that vulnerability for me to update my product and roll it out to our customers. And that is a bit problematic. When you're looking at that dependency, well, again, you need to wait on the vendor or the public library, the contributors that are building that library to fix it, then for you to like go quickly through your remediation cycle and then roll it out to your customers. If you have the luxury of being a SaaS product and you're hosting it yourself, it's going to go faster and you're going to roll it out as soon as you have the fix to all your customers, and it's going to be minimum impact for them. But if you actually have your application being an on-premise product and that's deployed in the customer environment, you need all your customers to go deploy, configure, and so on and so forth, the new version. And this was a huge problem like a year ago when the Log4j vulnerability showed up and half of the internet had to patch their applications in their systems. Now, this is also a good and a bad part as well, right? Because at the end of the day, we're optimizing, we're automating as much as possible for the entire build chain. So from that perspective, we have a way faster way to like develop new applications, a way faster way to go to market, and you're reducing a lot the load on your engineering teams as well. So at the end, they're using third-party libraries, and maybe it's going to be 80 to 90% of the code that's being in your application is going to be based on third-party libraries, most of them open source. That means you have only 10 to 20% of the code that actually needs to be built by engineering teams to deliver a new application. Way faster go-to-market, way faster response to any new functionalities, and so on and so forth. But it's a huge problem when it comes to like maintaining those ones. In the past, was mostly seen as like a black box. I'm bringing them as part of my code. It's solving my problem. I move fast. I deliver what needs to be done. And this is actually something that the focus was mostly on, like how we can automate the entire process, how I can build that pipeline, and how I'm always going to trust what comes from the outside because it's coming from an official source, being, again, a public repository, being a known vendor, and so on and so forth. And the focus was how to build a more scalable solution and how to actually grow that one faster, because everybody's going as much as possible after like new functionalities, how you can actually build more flexible solution to respond to a huge amount of traffic, increasing time. We always think about the future on how this product's going to have a lot of success and so on and so forth. You're not looking at like, hey, is this library I'm bringing in potentially going to be a supply chain attack for all my customers? Now, as you can see here, it's not just the, let's say, SDLC or the CI/CD as a process that evolved significantly in the last couple of years. It's also application security is trying to respond to that evolution. So before you had traditional solutions of addressing the security or the application security of the SDLC process, now there's a lot more new markets and new types of products that are being brought to the market in order to respond to this new need. And you can see on the left side of the hype cycle, there's a lot more when it comes to like how we can handle from like SBOM and posture management and configuration and so on, than your traditional, I'm going to put a WAF in front of my application and I'm good. Right? So it needs to spend a lot more time on like how I can actually shift left that responsibility, not as much as like what's going to happen once I'm in production. And again, I'm referring to Gartner to be like one of the most renowned sources. As you can see, there will be a lot more breaches, a lot more attacks will be actually happening because of the supply chain attacks, because these are the ones that's easier to bypass since there's not a formal process of onboarding these new applications. And this is the part I'm trying to emphasize. And if there's one takeaway from this meeting, this presentation, is this: we need to have a formal process of adopting these new libraries, new technologies that are being brought in. We're spending a lot of time on enterprise business, let's say, to onboard a new vendor to make sure that, I know, the endpoint security product is doing everything that needs to be done. There's a huge amount of effort to like validate all that. But when it comes to like securing your SDLC, it's minimum to none. And again, going back to the same report from Gartner on like how this should be built. And I really like this diagram because it showcases the three different areas that are so critical, right? On the left side, you're talking about like, what's the development cycle looking like? What can you do as part of your development cycle better? The one in the middle is strictly about like provisioning the environment and how you can configure it, since misconfiguration is such a big part of data breaches and so on. And on the right side is actually what happens when you actually make that operational, when you go in production and you want to actually monitor your application. And it's not just as much on the idea of like, hey, let's see, I don't know, if I have a bug to use an APM product, or I'm going to put a WAF in front of it for, I don't know, botnet protection, OWASP top 10 and so on. There's a lot more. And this is the part I think is very interesting for everyone. Like legacy or like traditional thinking was that application security, it's all about vulnerability and vulnerability management. And it's not at all of that, right? There was a lot of breaches. People were publishing libraries on GitHub. Then they were publishing also with their AWS credentials and so on. There were crawlers picking that up and spinning up crypto miners in their environment. Overnight, they had like tens of thousands of dollars of spending, if not more, in crypto mining. And then the next part that became quite critical was malicious libraries, right? And this is just like the policies in most companies. It was application security. We need to fix vulnerabilities. We need a proper vulnerability management solution. We need to like aggregate everything, and for us to like figure out a plan to like go and patch this and so on. But at the end of the day, it's not just about that. And this actually, the PyPy screenshot here is taken from literally yesterday, where they blocked pretty much any publishers, like any new users, the registration, but also publishing new libraries on PyPy, because they were using this to distribute malicious libraries. And you can see on the right side from Node, from NPM, like 25 examples of malicious libraries, the same exact thing. They're not going after the end user. They're actually, the attackers are providing a malicious library that you're going to embed in your product, and you're going to deliver it with your product to your end users. And this might actually be, let's say, it can actually go after your infrastructure, or it can actually try to steal the credentials or like password sniffing and so on from your end users as well. So depending on the library, they will go after you and your users. And this is why it's so important for you to choose carefully what you're bringing in. You're supposed to vet not just from like, hey, this actually solves my problem, how fast it solves it. Is this a trusted source? Can I make sure that who's contributing this one is not going to inject something malicious in the future? And when it comes to like how you can secure a SDLC, right? You need to scan a lot more, being like scanning your code, scanning your builds, while probably like nightly builds whenever you're building this one, but also part of your release cycle. And then once you're going in production, you need to monitor those deployments as well. You need to make sure the configurations are correct. Again, not providing any like misconfiguration that can expose too much information that might be exploited afterwards. You need to scan your containers, and even though those containers might not have any critical vulnerabilities today, it might have tomorrow or day after tomorrow and so on. And those images need to be scanned, patched, and so on. Even if you're patching those images, you need to make sure the ones that are running in production are doing the same thing. So it's so important. You have different phases of your application cycle that you need to prevent. But at the end, there is the same technologies behind the scene, more or less, that are doing the provide the protection, right? And this is for malware. It's malware protection and prevention, checking for secrets, and checking for vulnerabilities. And as a quick takeaway, this is 2 cents about OPSWAT as well. We provide what we call Defender Defender platform, and we're providing the technology stack, if you want, through Defender Core, that's allowing you to do malware scanning using over 30 anti-malware vendors, so pretty much crowdsourcing the intelligence from all these vendors, check for secrets, check for vulnerabilities, sanitizing content, so on and so forth. And this got a lot of traction nowadays in this DevSecOps use case where people are integrating with their Jenkins or any kind of build system they have through the API, but it's being used in a lot more use cases as well, right? I know kiosks heavily used in US nuclear facilities, almost all of them around the country, to like scan media. We have the storage product that's being used in the cloud to scan all the files deposited in S3 bucket or Azure Blob and so on and so forth. I kept integrated with load balancer and WAFs for scanning and sanitizing files. So all in one, this is providing like an end-to-end way of like analyzing all the files that are coming in your organization, but they're also leveraging or by your organization. So this might mean also the Docker containers, maybe not just the libraries that are coming from outside. Those should be scanned as well. Scanned for malware equally as the ones that you're publishing to be used by you or your end customers as well. So it's not just about like, let's have an email solution in place or scanning the files we're downloading from the internet. It's exact same policy should apply to anything in the application cycle as well. Being a PDF documentation or end up with, like I said, an open source library, a binary, or even like Docker containers and so on. And this needs to be rescanned periodically, right? It's not enough that you're doing a snapshot now and you're validating that one. Yes, this container was validated today. This might actually become non-compliant tomorrow. And it's not just vulnerabilities. I keep repeating that part. It's going to apply as well for malware scanning as well. It's going to apply for secrets when you're actually publishing this one. Whenever you have a new developer checking in code, you need to go and validate that one as well. And those are the measures you can actually put in place as part of your development cycle to make sure no one is bringing in a malicious library or a malicious container as part of your application or as the application shipping to your customers. And with that in mind, thank you very much for your time. I hope you enjoyed the conversation, and please let us know if you have any other questions.